What's up, YouTube? Welcome to my channel. Here I have a box came in the mail today. Super excited about it. Not only because of just what's in the box, but because all the other junk I've been buying off of eBay lately. Hopefully we can get everything working together. I have some really cool stuff. But let's open it up and see what we have. Well, it's packaged really good. I wonder why the box was so big. Oh wow, it's way bigger than I thought it would be. Alright, well let me pull it out and we'll take a look at it. That is huge. This is a Digital Equipment Corporation DECWriter IV. So Digital Equipment Corporation think up and made like a PDP-11. Yeah, so this is a teletype, and can use it to communicate with older computers that don't have monitor outputs and keyboard inputs and stuff. So it uses RS-232, and it's just basically like a terminal computer, but they used these before they had terminal computers. And yeah, so hopefully it works. Have a letter, it says important information enclosed. So I don't know a whole lot about this. It's considered slow for a teletype. It does 30 characters per second, which seems pretty fast to me. Has a cable, a serial cable, and a power cord with it. So typewriter feels really nice for the keyboard. And I know they had versions that had like number keys and stuff here, and some of these didn't have a keyboard. They were just used as a printer. But man, this thing's so much bigger now. I thought it would be about this big, you know, from the pictures online. Let's turn it around. We have our serial output over here. Looks like a fuse, power. About all that's on the back. So there's a couple versions of this. This one was one where you just had to manually feed in paper, and then they had a version that would take track paper so you could leave it unattended. And they also had an upgrade, and I think that's what this is. So this is supposed to somehow clip onto here, and it has the feeder mechanism for the continuous paper. So here's that mechanism. So see, these little cover plates, I don't know if you can see them, I think pop off. You clip this down in there, and this has the little, I think they're called tractor, it's a tractor wheel or tractor guides or something to feed the paper, you know, the paper with the holes on each side, and it's driven by this gear over here on the side. So you put that in there and it keeps the paper good and straight. So I lifted the cover up. Here's the cartridge and I guess the print head or whatever, and the belt looks to be in really good shape, which is awesome. There's another belt over there, motor to drive it. Yeah, it'd be awesome if this just works. There's some dip switches down in there. I think that's where you set the baud rate. And so this thing, there's a way to power it up. The manual's online for this, which is great. There's a way you can power this up and actually configure a lot of the settings, such as baud rate and the, you know, parity bits and stuff like that for the communication. So we'll have to go through all that. Nothing really seems broken. I did break. This goes right here, and I broke the tab off. I was opening it, unfortunately, just wasn't paying attention. It's old plastic, it's yellow, and it's pretty brittle, but hopefully we can glue that back together. But yeah, this thing seems to be in really good shape. Just a little dirty. I don't know if we should just power it up or if I should open the back up and see if there's anything we should worry about. Let me look over the manual and see how we open this thing. I've printed out a couple of pages from the manual. So it says little clip right here, so on each side. If you flip them back, and that takes this part off. Then it says to remove this. Like that, so I had to press these tabs right here. Small blade screwdriver, release the 4 snap fasteners to secure the printer housing to the base assembly. Okay, so I think that's going to be these. So I think if we get a screwdriver and pry those down, they'll pop down. And that should release the top cover. It should just come off after that. Alright, let's see if that works. That's pretty cool. Alright, did that get us anywhere? So the power supply is on the back. Got a random nut in there. See a couple big electrolytics in there. Or not real big, but fairly big. Right there. A green one and a blue one. Let's see if that power supply comes out anyway. So it looks like we can't get this power supply out without taking a lot of stuff apart, but there's nothing in there that looks too crazy other than just some electrolytics. I don't see any like refills or anything. I don't even know if they existed in this time frame, but I think what I'm going to do is just power it with the Variac and just bring it up really slow, like over hours, and just kind of go 10-20 volts every so often, and that way give those capacitors a chance to kind of come back around if they're going to, and eventually we'll get it up to full power and see if it works. So I'm going to work on that, and in the meantime, let's check out these labels. They're nameplates. They're kind of cool. So this is the label on the power supply. It says Rev A, part number H7834. It's got some tester markings on it. Over here, label for the back of the machine. It's got a 3 amp fuse in it, so if anything too crazy happens, imagine that'll save us. That's pretty low. So here's something else that's cool. This whole machine you can lift compartments up and stuff for maintenance, and of course it was a commercial machine, so people would be doing maintenance on it. But flip these tabs, you can tilt the keyboard up, and you can see the board down there. So you can't see all of it, but get a light. So this is the Intel. It says AM8085 ACC. I wonder if that's a 8085 processor. Something. There's another Intel chip. It says 8251A, P8251A. It's an AMI chip. It's 8020 CV. So we have to look some of those up and see what they are. But hopefully we won't have to dig into that. Hoping this thing will just work. But we'll start powering it up with the Variac, and we'll come back when we get it up to power or something smokes. So I got this thing over here cooking. I'm kind of tell you what I'm doing. So basically Power comes in here. It's got a switch. There's a transformer, and then there's some capacitors, and then there's some stuff, and then a transformer, and some more capacitors. So with the switch on, I would think the voltage is definitely getting to the first capacitors. And since it's probably a switch and power supply, those last capacitors may not be getting anything. We may hit a certain voltage and they just come alive, so it may be kind of pointless. I don't know. Also, these machines weren't sold until '82, which had to be the end of whenever they were even making these things. And so I don't know how long it's been sitting. It may have been used fairly recently, so it may be a waste of time anyway. But anyways, so I started off at like 10 volts, and every 20 minutes or so I was bumping it up 10 volts. And so where did I get that from? Just seemed right, made it up, I don't know. So I got this thermal camera here. It takes a little while to cut on, but every time before I bump up the voltage, just kind of go over it and make sure nothing looks hot. You can see some orange stripes there, but it's I think it's just a reflection from the metal. And if you put my hand there, you can see, I mean, it's not even hot at all. But yeah, everything seems cool. The switch may be bad. It may just be wasting our time. I just don't know until we get there and see if it does something. But it's been sitting 20 minutes or so. I'm going to bump it up. We're on 70 volts. We'll go up to 80 and let it sit a little bit longer. So we're sitting up here at 105, 110 volts. You see that? Yeah, I realize if I pull this cover off over here, we have some access to voltages. There's nothing anywhere. I mean, hopefully we get it up to 115 volts and it just comes alive. It is on the 115 volt switch setting, but it's not looking good. It's got me a little bit worried. If I cut on the thermal camera, we do have some heat. Nothing from the capacitors. The capacitors are all cool. We have a little transformer over here. Wait for it to calibrate. I mean, it's saying like 114, 130. I don't feel any heat. And then we got some real hot resistors over here. And that's saying 137. I mean, it seems a little warm, but like I say, I can't feel anything from up here. I don't know, we might have to dig into that power supply. Look at this little fella right here. Wonder if that has something to do with this little fella right here. Does that need to be like, oh, how do we even get that on there? We don't have the part that makes it go to the place. Alright, well, that's sitting on top of the sensor. See if we have voltage now. Nope. Power supply is just not putting out anything. It's not putting out nothing. Well, I guess we're going to have to pull this daggone thing apart. Alright, well, it is the next day. Brought the power supply up slow. I did find some schematics in a technical manual. And so it looks like power comes in, goes through a power switch, and then through a transformer, which the output of that will give us what's called 12 volt startup. So I'm thinking that's used for the circuitry to provide power to it before the regulation starts. And then we go through, looks like a rectifier, then we have our transistors for switching to the primary of our second transformer. And the output of that will give us, looks like 5 volts plus 21 and minus 21. The 5 volts signal goes into the regulation circuitry, so it's just a regulated 5 volts. And then the plus 21 and minus 21 go down to some 12 volt linear regulators for plus minus 12. I don't see anything that is like an enable signal from the main board, so I don't see any reason why we shouldn't have voltage on our output from the power supply when we cut the power on. So it looks like the power supply is just not functioning, so we're going to have to figure out how to get that out. It looks like maybe we just have 2 screws here and then 2 over here that you can't see, and then pull the power plug out. Hopefully it'll just come out after that. Okay, so here's our power supply. Unfortunately, the way it is in here, there's no good way to power it up and measure things without taking it apart. But I think what I'm going to do is just kind of go through the best I can with a meter and see if there's anything obvious, like, you know, some bad diodes or shorted transistors. Here's our schematic. I don't know how well you can see that on the camera, but these are the 2 big capacitors over here. We need to make sure those are discharged. They do have resistors across them, but something could be broken. But those are 200 volt capacitors, and want to yeah, make sure those are completely discharged. But we have a lot of diodes. We were getting some heat over here according to the thermal camera, and also this transformer was warming up. So I imagine we're at least getting voltage to here. These transistors here control all the downstream power, which we don't seem to be getting. I'm going to check these transformers, make sure that there's no opens in them, and yeah, check all these diodes, make sure none of our transistors are shorted. Check some resistors, and just use that as a starting point. See if anything jumps out. If not, we'll have to pull this thing apart so we can get it out. Alright, so I confirmed there's no high voltages anywhere. I've checked all the diodes I can check from the top, and everything's looking fine. It looks like if I take this power plug out here, this PC board will just slide out, and then maybe we can reposition this bracket and not have to take any of this stuff apart and still be able to power it up. Okay, so I have checked the windings on all the transformers. Nothing seems to be open. The diodes all seem fine. So that's all good. This is the main switching transformer for the switching transistor for the transformer, and I checked the pins on it, and 2 of them were shorted, but they're across the winding, so we can't really measure that. So I think what I'm going to do, I've got it on the Variac. I'm just going to slowly bring up the power a little bit, maybe 20-30 volts AC coming in, and just start measuring things and see if things are working. So this is the rectifier for the 12 volt startup, so we should have some AC coming to this side of it and some DC coming out that side, and this would be the positive and negative wires right here. Nothing's labeled on here, so just kind of have to figure it out from the schematic. So we should have that no matter what, and also we should have some DC across these capacitors no matter what. The voltage would be split across them, so if I'm running 20 in, it'll be like 25 or 30 DC split across the 2, so maybe 15 each, and that'll tell us we're getting all the way to the primary of the switch and transformer for the power supply. and we can measure some voltages on the output. I imagine we'll be getting voltage to the primary and not to the secondary, and there's something going on with the switching, which is all of the second page stuff. So there's op amps and there's a PWM chip in there. So a lot of things that can go wrong there. But let's at least make sure we've got the basics covered and we are getting voltage to the primary of the switch and transformer, and our control voltage to our regulation circuitry. Alright, so the Variac's turned up. It says like 20, 25 on it. Let's go to AC and see if we're getting any voltage. Let's get you where you can see the meter. So two of these pins should have voltage on it. So we got 25 there. One of these is ground. So it looks like these are the two. Our input voltage from the Variac. We got 27 AC coming in. So we should have something on the secondary of this transformer. Let's say we got 4 volts. So that's AC. So if we switch to DC, we should have some DC voltage here. And we do. So that's our startup voltage for the switch and regulator. So that's good, we have that. Let's check the voltage on the main capacitors. 33 and 33. Alright. That's more than I thought it'd be, but it doesn't matter. We do have voltage there. So I guess we should look at some outputs. See if the switch and regulator is actually doing anything. I assume it's not. Which you can see from the schematic, they're connected straight to the pins, so we already know they're not. So this should be 5 volts. It's interesting we actually have something on there because I wasn't reading anything before. Let me turn the voltage up. So we're up around 50 volts now. Go ahead and do a full power test real quick. And that should be about 120 volts. Yeah, we're not getting anything on the 5 volts output. So it doesn't look like we're switching. So while I got the full 120 volts coming in, let's check the 12 volts startup voltage and make sure that we are getting something around 12 volts, because that's going to be critical for everything to work. So I'll cut it on. I mean 12.76, so that should be perfect. Alright, I'm going to have to study the schematic a little bit and figure out how we can go about troubleshooting that. Let's take a quick look at the schematic. This is the second page, so we can kind of see what we need to look for as far as signals on the oscilloscope and voltages. So here on the left, you can see we have this plus 12 volt startup. We also have it up here at the top. So that's the 12 volts we have available before the power supply starts up. And if you follow, let me zoom in. If you follow this 12 volt startup, you'll see after this 215 ohm resistor, there's a 5.1 volt Zener to ground. So this spot right here is regulated to 5 volts. And you can see that comes up here into this op amp. So before we go over the control circuitry up here, let's look at this stuff on the bottom, because there's a lot going on and there's really not a lot to it. It only really affects one signal to the whole circuit. So you can see we have 5 volts coming in here, and that's also the 5 volt, well, that's the 5 volt output from the power supply, the regulated 5 volt output that's created by this circuit. So on startup, this won't exist. We have plus 21 and we have minus 21 coming in here, and then we have these 21 volts return, negative 21 volt current sense, These current ones are going across shunt resistors. You see there's one for 5 volts, there's one for negative 21, and one for plus 21. And then up here we also have the 5 volts coming in from the output of the power supply that is compared to the 5 volts that's created here with this Zener circuit. So this right here is the over voltage for 5 volts, and these down here are over current. So none of these should be, you know, causing a problem right now because we don't actually have any output from our power supply. So these are 339 op amps, LM339s, and what's special about that op amp is that it has an open collector output, meaning that it can only pull the signal to ground. It can't actually like output a voltage, which means that voltage has to come from somewhere. And you can see it comes up here from this 240k resistor going to the 5 volts, and also this 39k resistor going to the 12 volts, so it's probably around 10 volts or something like that. So the first thing we really need to check, you can see if we follow that up here to this 556 chip, that it's going into pin 6, we need to make sure that that is high. That should be high at all times. It would only go low if there's some kind of an error being detected down here or some faulty circuitry. So that's number one. So let's take a look at each of these circuits up here. So this, on the top left, we have a 301 op amp. Being fed into it is our 5 volt output from the power supply and also our 5 volt reference. And looking at this circuit, it looks to me like it's an integrator. And I say that because we have a 56k resistor feeding back, but it looks like the majority of the current during the transition, you know, as the voltage is changing on the output, it's going to be passed through this 8200 picofarad capacitor and this 1k resistor. So what that's going to do is as the output on pin 6 increases, it's going to allow that voltage to pass through that capacitor momentarily and satisfy the op amp, but then this capacitor will charge up and then the process will have to start over. So what you end up with is like an upward slope as it cuts on, and if it were to cut off, then you'd have a downward slope. So that's what that circuit looks like to me. This transistor, I'm not 100% sure what it's for. It is, the base is connected to the 5 volts signal, but I imagine this has to do with preventing multiple pulses per PWM cycle, but I haven't quite wrapped my head around how that works. So if we move over here to the 556 chip, this is what I was calling a PWM chip earlier. So a 556, LM556, MC556, that's two 555 timers in one package. So you can see some of these have like a 1 after them, and some of them have a 2 after them. So that's our two 555 timers. So if we look down at number 2, you can see we have our trigger and our threshold tied together, and they are going to a capacitor to ground. There's a resistor up to the discharge and then another resistor up to our 12 volt startup. And that's a textbook oscillator. If you just were to Google 555 timer oscillator, that's the circuit you would see. The frequency of that oscillation is going to be determined by these values right here, but we should see on Y2 some type of a square wave at some frequency. So if we follow the output of that 555 timer, you'll see we have a diode, and then it's tied into the threshold of the first 555 timer. And because of that diode, you can see that on the 0 volt output from the first 555 timer, it's going to pull this signal down. But then on a high output from that timer, it's not going to affect it at all because the diode's going to block it. So we know that on this pin 1 and pin 2, half the time we should have 0 volts. So, you know, just based off the two things we said here, we should have like a, let's see if I can draw. We should have like a signal going up, and then it should cut off for some amount of time. And then a signal going up, and then it should cut off for some amount of time. Now I suspect since the 5 volt output is being fed into this op amp, it's going to affect the slope of this. So we'd get a slope like this, or we could get a steep slope. And I guess that's where I think maybe this transistor comes into play, because we'd want it to cut off and then stay off until the next cycle. But what I think would happen normally is it would, if you had a fast slope, is it would slope up and it'd stay on for a while and then cut off. I don't think that's what we would want. I think we would want that sharp cutoff there. So I'm guessing that's what this transistor does. So if we move on to the output of that, so okay, so also this error signal from down here is being fed into the trigger. So that's effectively going to make Y1 not oscillate or not create a PWM signal whenever that signal's low, and it will allow it to whenever it's high. And whenever this gets triggered, it's going to be based off of the threshold voltage, which is determined internally by some resistors in the 555 timer, plus the voltage going to this pin 3, which it looks like is going to the 5 volt signal. So basically what's going to happen, I think, is when we get the signal coming up from the op amp, it's going to cross some point and our PWM signal is going to cut on. And it's going to keep continuing up until that voltage drops off, and then our PWM will cut off. So for like a small PWM signal, we'd want a short pulse width like that if we're just trying to increase the voltage a little bit. Or if we wanted a bigger change, we'd need a longer PWM signal like that. So I hope all that makes sense. So the output of this is a little confusing. This output's going into what I'd call a pulsing transformer, and it triggers the main transistors that actually supply the signal to the switching transformer, the main transformer that actually gives us our outputs. And you're going to want that to go positive and negative with an equal duty cycle. If you were to just give a positive square wave, like the output of the 555 timer, then you're going to saturate your transformer. It's going to keep hitting it in one way. It has to be balanced, so something has to bring it back and forth. So you can see there's some more voltages coming into here. We have T3 pin 3 and T3 pin 6, which if you look on the other page are going to be our, I think, the positive and negative 21 volts. But those don't exist until the power supply is functioning. So all we have on startup is this 12 volt startup. So I imagine this is probably either just pulsing it with 12 volts to ground momentarily to kind of get the thing excited and going until these 21 volt signals come in, or it is splitting it somehow in here to where it's basically going positive 6 and then negative 6. But on startup, I think there may be some weirdness that goes on, but once it gets going, I'm pretty sure this circuit's just designed to give it an equal positive and negative pulse going into the pulse transformer. So I'm pretty sure that's what that's doing, but that's basically all that's happening here. So what we need to look at is this error signal on pin 6. We need to look at the waveform going into pin 1. We need to look at the output of Y2 to make sure we have a square wave. So probably pin 6 to make sure our error is not pulled down, then look at Y2 to make sure we have a PWM signal. Then we'll look into pins 1 and 2 and make sure that we have some kind of a wave like this or this. And then the output Y1 should be our PWM signal. So we're not seeing any of that right now, but now we have an idea of what to look for. So let's go and take some readings.
Just for giggles, I got out the thermal camera and kind of get an idea of what's getting warm. It looks like that chip's got some heat on it, or maybe the resistor above it. That's the actual chip that's going to supply the PWM or the switching to the power supply. So that transistor may be getting a little warm. It's hard to say because some could be reflections. But over here, this is the input side. This is kind of interesting. So we have two power resistors up here, and it looks like the one on the right's getting warm and not the one on the left. So I have to look at the schematic and see if that means anything. And then down below, these two resistors are getting warm, which I think those are the bleed off resistors for the capacitors. So that might make sense. And I'm only at 50 volts on the input right now, so not giving a lot of power. Of course, that's all the way up to 90 F. It's probably 75 in this room, maybe 80. So maybe it's not very hot, but maybe a clue. It's just kind of interesting. Only one of them's getting warm. Yeah, so I was reading through this schematic and actually found something really interesting. And so this chip, I was saying it was a PWM chip. I was just kind of assuming it was. But it's actually an LM556, which is the same thing as a 555 timer. It's just a dual package. And that's really interesting because I think a couple of days ago I was watching an MSI guy, and he does this chip of the day series, and he had some LM556s and made the comment that he's never seen these used anywhere and didn't know who would use them. So they're actually using it as a PWM source here for a switching regulator. So that's interesting. Well, I'm going to keep digging through this and we'll see if we can come up with a plan. Alright, so I got my favorite little scope set up. Somebody mentioned before, you know, why don't I use one of my nicer scopes? And I just don't have a good setup here. This is a nice little portable one. It works fine. I really like this scope for doing things like this. So look at the schematic. So here is our error voltage. So I've got everything powered on. So this error would go to 0 on the output pin 6 if we had 5 volts. This is, you know, in charge of doing our regulation. And so since we have no voltage output, pin 6 should not be 0. It should be something higher than that. So that's this chip right here. So I go 4, 5, 6. And you can see we have voltage. We've got 2, 4, almost 8 volts there. So plenty of error. Then if we go to our 556, let's make sure that we are actually getting our pulses on our second 555 timer. So pin 9 should have some square wave on it. So let's look at pin 9. Try to not short anything, and we do. Looks like it's around 37 kilohertz, and it's like a 11 volt peak to peak. So that looks pretty good. So now if we come over here, need to look at these signals coming in. So pin 1 should look like our output. I think that should look like our PWM signal to the transistor. So let's look at pin 1. Pin 1 and pin 2 are tied together. So either one of those. And that looks nasty. That's ugly. I would think that means that one of our error signals coming in, like we're getting over voltage, which isn't likely, or probably more likely one of the overcurrent protection op amps is kicking in. So let's go to pin 6, which is our trigger for the 555 timer one, and I would expect that to always be up around like 12 volts or 10 volts or 9 volts or something like that. So it gets pulled down towards ground if something's wrong, if one of these devices has failed or if it's detecting an overcurrent situation or something like that. So let's look at pin 6. And that's all the way down. That's all the way down. So something in the lower half of this circuit is not happy. So we need to see if we can figure out which one of these is triggering it. Unfortunately, we can't just look at the output because they're all tied together. So they're all going to read the same thing. So you have to see if we can figure it out from the input. I think the easiest one would just be the 5 volt over voltage, which we don't have 5 volts on the output, so that should not be triggering. But pin 10 should be connected to the output, which we're reading about 0, so it should be really low. And pin 11 should be 5 volts. It's regulated to 5.1 by the Zener right here. So look at 10 and 11.
That's 10. 11's 5 volts. And pin 10, is like 1 volt. Which is interesting because it's, if you look at the actual schematic, we're measuring it after the diode. And right here is the actual pin header, and we're reading 0 volts. Which kind of suggests maybe one of these capacitors is shorted right here. And all the voltage is dropping across that resistor. I don't know what resistor that is. It says 5 watts. So it'd be this one right here. Let's just measure the voltage across that. And see if we're losing our 5 volts. Maybe we've got a 5 volt overcurrent condition. No, we're not dropping across that. Yeah, it is 0.1 volts. Yeah, we're getting 1 volt on the output now. We were getting nothing before, so. But it's been on for a while. Maybe something's coming around. Getting no voltages on anything else. It's interesting. I think anything's getting warm. Okay, so let's continue looking at error signal op amp. Okay, so anyways, unless the op amp has failed, this one should be off. It's not being triggered. Okay, so this is the output voltages from the switch and transformer. And you can see that each output has a 0.05 ohm resistor. And those are used as shunts for measuring current. So you can measure the voltage across those resistors and determine the current coming out. And you can see all of those signals are fed down to tags down here. So if we go to this page, we've already checked the overvoltage protection. These are all the current protection ones. And they just have the inputs from either side of that resistor going into these. So if that voltage across the resistor gets too high, then you know the current's too high, and these should pull down. But all these should be reading 0 because we have no current, or we shouldn't have any current. So let's look at 4, 5, 6, 7, 8, and 9. Let's look at the pins first and see if we see anything. It might be better to actually go across the resistors with the meter and see if it's just a little tiny voltage. I'm not sure what the threshold voltages are going to be here without going through the circuit, but let's take a look at these pins and see if we see anything interesting. So it's 4, 5, 6, 7, 8, and 9. And 4 has nothing. 5, 6, 7. Pin 8 has something on it. Pin 9 has something on it. That's our 5 volts. So what do we have exactly? It says 884 millivolts. (900 millivolts). So we've got about 20 millivolts going across that current sense resistor. So which one was that? I said that was 5 volts. It's 8 and 9. Yeah, 8 and 9 is the 5 volts. So our 5 volts is the only one that's actually outputting anything. It's outputting like a volt. And we're getting like 20 millivolts on here. So yeah, let me think about that for a minute. So if we go back to the 556 timer, I don't think we actually looked at the output of Y1, which is on pin 5. We looked at pin 9. Which does have a PWM signal on it. Right there. But if we go
to pin 5, which should be the pulses that are triggering this transformer. There's nothing happening there. Yeah, there's nothing happening there. I think it's just triggered all the time. So, why are we getting 1 volt on the output of the 5 volts here? So, I mean, this is a closed system here. You see, it's just a transformer hooked to the output. The ground is grounded, but as far as the 5 volt, there's nothing hooked to it other than this current sense wire. So the only way that it can be getting that 1 volts in there has to be just that op amp backfeeding, which isn't a thing op amps do. So I'm kind of feeling like we should replace this 339. Might be a starting place. And do that before we go any farther. It's an easy enough thing to replace, and I'm kind of worried about that pin 5 being high all the time. So what would that do? So it would cut this on, which would pull down T2 5. And T2 pin 6 is current limited, so maybe it wouldn't do anything, but we're basically just cutting that transformer on all the time, it looks like. So, but the transformer wasn't open when I checked it, so I think we just need to replace that chip. And I think I remember when we were doing the thermal camera, one of the chips had some heat on it. Was it that one? So that'd be this chip over here, LM556. I mean LM339, which is the op amp. No, it doesn't appear to be getting warm. We got some warm resistors, but it's not getting warm. But I really think it's backfeeding to the 5 volt output. So let me see if I have one of those. If not, we might need to order one and see if that gets us any closer. Aha! Looked at my boxes of chips and found the LM339. Don't know why I have this or where it came from, but yeah, I'm gonna swap that out and let's see if that gets us any closer. Be really cool if that's what it is. If not, it's probably gonna be this transistor or that one that actually do the switch into the power supply. But they're not gonna switch without a PWM signal. We're not getting a PWM signal on the output, so let's try that. All right, got the new LM339 quad op amp open collector IC replaced. I'm just gonna hold my meter on pin 1. I've got the variac turned all the way down, so we'll slowly turn it up and this voltage should come up. It was pulled to ground before, which is basically disabling the PWM. So it's already coming up, so that's already something different. I'm up on 25 volts. So let's look at pin 1 of the 556 dual 555 timer chip and see if we see better looking pulses. Can't do it with that though, that's a meter. Oh, let's get the scope out. Wish I had one of those cool things that you can, it has a little pin sticking up in the clip, especially with this. This has got a lot of high voltage on it, it's kind of dangerous. Alright, I don't know how the meter's set up, but we'll let's see, we can look at pin 9. We got some little pulses. Pin 1's got nothing yet. Oh, it's coming alive. It made some buzzing noises. I don't know what voltage we're on, probably like 100. That's more what I would expect. That looks good, and look, it looks like it's kind of trying to regulate or something. Let's look at the output voltages. We're not up to full line voltage yet, so don't expect it to be working, but should be doing something. Okay, so these two are ground. That should be 5 volts. Already got 5 volts. Awesome. Let's see what the others are supposed to be. They're not really referenced to this pin 1 like I have it. So we probably won't get exact voltages on the other ones other than 5, but pin 3 is 5 volts. Pin 5 is negative 21. Negative 18 sounds good. Pin 6 is positive 21. Oh, that's not right. 6 is negative 21 return. 7 is positive 21. That was good. That's opposite of that one. And those are unregulated, so they're probably going to go up with input voltage, maybe. I don't know. And then 8 and 9 should be our plus and minus 12 volts. Alright, that was it. It was that op amp. That's awesome. Kind of took a shot in the dark there. It could have very well been the switch and stuff here. Just didn't really have a good way to test it. And can't get anywhere if the op amp's pulling the error signal on to the 556 chip uses a PWM chip. So anyways, it looks like it's working. I haven't turned the voltage all the way up yet, but I assume everything is good. So I'm going to put this back together and we'll stick it back in the machine and see if it works. Alright, I got the power supply back in the DECWriter, and I haven't powered it up yet. So let's give it a try. We know there's a proximity switch here. Gotta have the cover on it, but I'll cut my isolation transformer on. See what happens. Definitely did something. That's cool. Alright, well I think I need to, at this point, clean the machine up. It's really dirty. And put the cover back together. We'll see if anything works. Alright, we're back together. See what happens. Well, we got a power fault. Have to look at the manual and see what that means. Stick a piece of paper in there and see what happens. Don't know how to do this. It's probably automatic somehow. Okay, I think I got it. This little lever right here you have to flip up for it to grab the paper. So, like that, and then cut the power on. That was too far. Try it manually.
Okay, so oh, that returns really fast. It's printing. That's cool because it's got that old printer cartridge in there. So, yeah. I think we need to figure out how to hook this thing to a computer. Get a little help. Okay, so this last part took me a little while to get working. I had to make this, which is basically a modem, no modem adapter slash DB9 to DB25 connector. Took me a little while to get figured out. I also had to figure out what what serial format this was sent at. It was 7 bits instead of normal 8 bits. Carriage returns, I think you normally do carriage return then a line feed. Or you can do a line feed, or you can do a carriage return. But this does line feed carriage return, which doesn't work with this. So no matter which one I set it to, I get some weird characters. But I finally have everything working. So that works, and the carriage return works fine there. It ignores the character, and then if I type here, see it shows up there. I wonder how backspace works. Yeah, that all has to be set up. See, so when I hit enter, it put this caret M, and that's the line feed or carriage return, whichever one I don't have it set up to do. So, yeah, and if I do it the other way around, then it messes everything up. But, so, spelled it wrong, but typewriter is really nice. The keyboard, really nice. I like it a lot. It's just like I guess a mechanical keyboard. Buttons come off easy. It just has 2 little contacts that get pressed together, that get connected whenever you press it down. But yeah, this isn't what it's for, so it doesn't matter if this works that great. But I wanted to be able to test it. I don't have any other. My computer's working, so yeah, looks like this is fully working, so that's really cool. I was kind of thinking it would just plug it in and it would work. I was just going to show off my new toy, but it ended up being a little bit of a project, so that was cool. But anyways, thanks for watching, guys. See you next time.